Okay, so welcome to today's class. What are some things that we have been going over lately? Why don't you just recap me? I'm a little fuzzy. What have we been doing lately?
2D shapes.
2D shapes, so flat, right? We've learned how to calculate your rectangles and or squares as well as triangles, and we know the formulas of those. Okay, good. I like it. Will somebody read what's on the board?
If Leslie is wrapping this box for her mom's birthday, how much wrapping paper does she need to use in order to fully cover the box?
Okay, so we are going around the box. I just want to make that very clear. We're not going to be there's going to be no overlapping with Leslie's wrapping paper. So does anybody have any idea of how we would figure out how to calculate how do we figure out how much she needs in order to cover? Yes, right.
Do we have to find the area of each side and then add them together?
Of each side and add them together. Why do you say that? I like that. Why do you say that?
Because then we would know how much wrapping paper for each side, and then we could put all of it together to know how much wrapping paper.
I like that. I like that. And that is called surface area. So when we're talking about a 3D shape versus a 2D shape, and we're just go 2D, flat, 3D obviously is not flat, not flat. It's called surface area instead of just regular area because you're finding obviously it has surfaces. So let's go this way. So what is, I'm going to label this side one, this first front side right here. So side one, how do we find the area of that side? 11 multiplied by 5. I'm going to draw it just so we can actually see it. 11 multiplied by 5, and you know that it's 5 because this side length and that side length are going to be the same. So that's going to be 55. Our units is centimeters squared. Okay, good. Is there another side that is exactly the same as that side?
Mm-hmm.
And it's what side?
The one on the other side?
The one on the other side.
Opposite from
This back one back here. You're good. Okay. So we're gonna call that side 2. So we've got two of those. 5 and 11, so 55 centimeters. Oops, squared. Can't forget that. Okay. Now what else do we have to do? What is another side? Pick another side for me. The top and bottom, and you know the top and bottom are going to be the same. So we'll draw the top because your voice, the dimensions are 11 and 2 because we know that by rectangles, opposite sides congruent. 11, 2, 22 centimeters squared, and we have 2 of those. I'm just going to put a little times 2 out here. I know that I'll remember that I have 2 of them. And then our last, we've got 2, 3, 4 sides, and we have a total of 6 on our rectangular prism. Fancy new word, rectangular prism, which are going to be these 2 opposite sides with dimensions of 2 and 5. So this is 2, this is 5, 10, and yet again, we have 2 of those. Okay, now you said, Riley, we would add them all up, right? Because we're trying to find the total of our whole surface area. So we've got 55, 55, 22, 22, 10, and 10. That's 20, 44, 110, 64, 174 centimeters squared. So that is the total surface area of what we need to do. And you'll notice, guys, we did use our formulas, but we only used them for we broke this down into 2D shapes, right? That's exactly what we did. We took our 3D shape and we broke it down into 2D shapes that we already knew. What's a lesson that we did earlier that we kind of did a similar concept? Do you remember what we did? What that shape was called that we broke down? No? Compound shapes. Remember, it was that really weird kind of funky shape. We had the triangle at the top. We split it in half to find the area of the triangle and then the square. Yeah, ringing bells? Perfect. So it's the same concept. We're just breaking it down into things that we already know. We already get it. We can already do it. And then we're going to add them all up. So If you were to answer this, Riley, how much wrapping paper does Leslie need?
174 centimeters squared.
Beautiful. Okay. Right now, well, this is when I would be doing a bunch of these just to get the repetition of it. I would leave out, what did I leave out for you to calculate? No, I might not give it to you in this like nice, pretty order. I might try to confuse you and put these in different spaces to see if you recognize that, you know, your shapes and do you know the attributes of your shape and all that great fun stuff. But we would go into surface area. From here we would go into cones and not rectangular prisms, pyramids, things like that, where we would yet again just break it down into shapes we already know.